Yes, student, good morning. My dear students, as you know, nowadays COVID-19 problem is going on a lot of. How do we all protect ourselves from it so that we can all be safe? First, wear mask properly. Second, stay at least 6 feet from others. Third, wash your hand frequently. And fourth, don't touch your face, don't shake hands, and don't share food and water with others. Dear student, in this way we can protect ourselves and other also. Thank you. Yes, student, today we'll discuss here exercise 13.1. This is the part 2. Question number 8. Today we'll discuss question number 8 here. The question number 8 is different type question of this other questions here. Question number 8. Suppose given limit x tend to here and minus 1 and x tend to here plus 3 and function here given कि x exponent 4 minus 81 upon 2x square minus 5x minus 3. Suppose you are directly using the identity here, directly using the limit here, so your result will come, answer will not come the correct here. Means suppose you are 3 exponent 4. What value of the 3 exponent 4? The 3 into 3 into 3 into 3. The 3 is here 9, 9 and 81. That means 81 minus 81 result is 0. That means total value of the function is 0. Total value of the function here 0. That means the value of this function is 0. This is not possible because you are finding the value of the function at x equal to 3. That means first of all you will factorize of this function, then you will putting the then you will using the limit here and you will get the answer. So now x exponent 4 minus 81, first this is the fair one, and first we will break down this x square ka whole square minus 9 is square. So then you will a square minus b square, x square plus 9 and x square minus 9. Again this portion again because you have minus sign here, so this portion again factorize here कि x square plus this is a plus portion is not factorized but minus portion is again factorized. It means 3 a whole square. You can write here कि x square plus 9 and here again कि x plus 3 and x minus 3. So this is the factors of the numerator part. Similarly, your factor of the denominator part here. So now factor of the denominator 2x square minus 5x minus 3. So 2 3 is 6. So you having factor is 6 means 5. The 6 plus 6 into 1 is 6 and 6 minus 1 equal to 5. You can write here 2x square minus 6x plus x minus 3. In this way, because 3 to just 6, 6 minus 1 is 5 minus 5x. The taking 2x common, what is left here? X minus 3. Here nothing is common, then taking 1 common, the x minus 3. Because you are taking the common here in this part 2x. What is left here? X minus 3. And here is nothing is common, then you taking the common is 1. X minus 3, x minus 3, again taking common here x minus 3. And what is left here? 2x plus 1. The factor of the denominator of this portion or factor of the numerator of this portion. Now putting of this value here. Now the limit x tend to 3 x exponent 4 minus 81 upon 2x square minus 5x minus 3. You will convert it to limit x tend to 3 here. You are only here, function is not changed, function is only the factorize. The x square plus 9 x plus 3 and x minus 3 or what will be here x minus 3 and 2x plus 1. X minus 3 are cancelled. What is left here? X exponent x 10 to 3, and what is left here? X square plus 9 and x plus 3, and here 2x plus 1. But suppose you are putting the here no any negative sign here, so suppose you are putting the value using the limit here, the result will be not come here 0 or not come here infinite, because here no any negative sign. Now using the limit here, the square of 3 here, the 9 plus 9, 9 plus 9, and here square of 3 is 9, 9 plus 9, or 3 plus 3 upon 2 into 3 plus 1. So what is that coming? 9, 9, 18 into 6 upon 3 to just 6 plus 1, 7. Here 3 to just 6 plus 1, 7. According, so you will multiply here 18 6 is 108 upon 7. So then this is not divided, then this is your final answer. Suppose you are divided complete time, then you divide, otherwise don't divide here. So this 18 6 is 108 plus divided by 7. So this is your answer. According this way, so this your answer is correct answer is 108 upon 7, not 0. In this condition your answer is coming to 0, but this is the wrong. In this condition you are, suppose you are directly using the limit here, so then your result will come here 0, but this one is the wrong answer. Your correct answer is 108 upon 7. After solving the complete proper method, you will solving the proper method, result will come in the correct. But directly using the limit, then result is 0. Sometimes answer is come the correct when you are using the directly, but when function is a rational form, so don't direct put the limit here. Sometime answer correct, but sometime answer is the wrong. So you will check the function is, suppose a function is given the rational form, so first of all you will convert these in factors form, and then which factor is common, then we cancel it, and then what is the left, then in left part you will using the limit, then you will get the correct answer. Yes student, the next question we will solve here. Yes student, next question I am taking question number 13. This is a different type of question. Question number 13 here, question here given limit x tend to 0 and here sin ax upon bx. When you directly put here 0, so what result come here? Suppose sin a into 0 upon b into 0. That means sin 0 is 0. This portion is complete 0. It means sin 0 is 0. What value of the sin 0 0 or b into 0? This portion is complete infinite. When you divide by the any number by the 0, the result comes infinite. So then this answer is the wrong. This answer is the wrong. So how to solve this question here? So you having the one identity here is sin theta upon theta. Here write the limit x tend to 0 equal to 1. So using this limit, then you will get the correct answer. So how to get this limit here? But here condition here given is sin ax upon bx. But here condition given sin theta upon theta. But here condition is ax upon bx. So then you will be x tend to 0. Suppose you multiplying by a and divide by a, sin ax upon b, write in this x, and ax. The a upon b, this b write the separate, or this a and this a multiplying here. But then sin you can write here limit x tend to 0, a upon b, do the separate here, and sin ax upon ax, this portion. So what value of this? According this identity, sin theta upon theta, value of this is 1. So then you can write a upon b into 1, result is a upon b. So this one your correct answer. First of all, suppose you will be directly using the limit here, the result will come in the infinite. So this is the wrong answer. After that, because question is giving the limit, the answer is not infinite, this is not possible. So then you will be something changing in the function, then you will be get the correct answer. So what's changing in the function here? You will multiply by a and divide by a. So multiply a and multiply a, both a and a. Or this b doing separate here, the a upon b doing separate as sin ax upon ax. So this identity is limit x tend to 0 sin ax upon sin theta upon theta, and theta tend to 0. You write theta 0 equal to 1. So then the sin theta upon theta equal to the value is 1, and then a upon b. This is your correct answer. Yes, student, next question will solve question number 14 here. This is the same question of the 13, but tricks will be double time using here. So now question given limit x tend to 0 and sin ax upon sin bx. Suppose when same condition, suppose you are using the direct here limit here, so what things here is sin 0 upon sin 0. Sin 0 upon sin 0, a value of sin 0 is 0, 0 upon 0. This result here infinite. But this is not correct answer. This one is not the correct answer. So what are here question number 6 having the only one portion, because you are having the identity limit is x tend to 0 and sin x upon x. So this result is 1. But condition here given is sin ax or sin bx. So how will you change it? You will be making the two identity here. This is the rational form. So you will doing the separate limit of this or separate limit of this. Then you will get the correct answer. So now you will solve here limit sin x tend to 0 and sin ax, and then again you can write here limit x tend to 0 1 upon sin bx. This is the rough word, the sin bx. The numerator write in this form and denominator write in this form. Then you make one identity here, one identity here. So then convert it limit x tend to 0. How it possible? Is sin ax upon ax. So then you will be multiply also here. When ax divide by, then ax multiply also here. Then next, and limit x tend to 0 1 upon sin bx. Sin bx, then you multiply here bx, and then you divide multiply here bx, then divide also here bx. In this way, then now you can write here sin x tend to 0 ax upon bx. So you write the separate way, ax upon bx. So you write the separate way, this ax and this bx, and then you write here sin ax upon ax into, you can write here limit bx upon sin bx. So what result? This value of this is 1 and the value of this also 1. So x means the a upon b into 1 or into 1. The result is come a upon b. According to this you get the answer a upon b. Because result of this sin theta upon theta result is 1. Similarly sin theta upon theta means you can write again bx upon sin theta. This also is 1. 1 upon 1 means 1 upon 1 means 1. So taking your result is 1. So when multiply this and you get the answer a upon b. So this is your final answer. When you putting the direct here limit using the direct limit, the answer is infinite. This is a wrong portion. You will be doing the separate this way, and then you find the identity here using the identity, and then you get the correct answer. Yes. The next question will solve here. Yes, student, next question will be solved. The next 23rd question. This is the important question, 23rd. A different type question. Rest question is the similar of the question number 12, 13, 14, but 23rd is the different type questions of. The question number 23, find limit x tend to 0 fx or where is function, where is your function, value of the function here, fx. What is the fx here? Function here given 2x plus 3 and 3x plus 1. The 2x plus 3 value of the function here when x less than equal to 0, this is the LHL limit, or the function is greater, this is RHL limit. When is the those limit having the greater than 0, this is called the RHL, or those limit is the less than of the 0, this is called the LHL limit. So this is the LHL limit, this is the RHL limit. RHL में greater than 0 means greater than 0, the right side of the 0, this is the RHL, or this is the less than 0 means left side of the 0, so this is the LHL limit. So then the value of the function of the LHL limit this, or value of the function of the RHL limit of this. So now in this type question we will solve here first using the LHL or RHL condition. So now find the value at x equal to 0. So then LHL, what value of the LHL here? Ki limit x tend to 0, represent the minus sign here, fx, or what value of the fx here? Limit x tend to here minus sign, or value of the LHL limit here 2x plus 3. Value of the function here, when is the limit we will using the LHL, the value of the function here, because this is the left side of the value, left side value of the function, means this one is the suppose function is the 0 condition, in this direction value the LHL, or in this direction value is the RHL, so means less than 0, 0 से less than this is LHL function value. So now after that we will solving here the limit s tend to 0, this will be converting s tend, x place you will be changing in the h, so then s tend to 0, then what value of the x here? So you will x place you will be h minus 0, you will putting here limit. So here you will write here to 2, what value here? Ki h minus 0 plus 3, h minus. So when you using the left hand limit, when you are using the left hand limit, so then h minus 0, or when are you using the RHL right hand limit, then you using the h plus 0. 0 means this is the your limit, this is h minus a and h plus a. What is the a here? A is the your limit, original limit. This is the original limit here, a. Don't put here 0 means a. What is the a here? A is belong here your original limit. What is your original limit here? Your original limit here 0. In this question here, the sometimes here 0, sometimes here 1, sometimes here 2, according this condition. This is your original limit. The sometimes here 0, so you put the h minus 0. Suppose you write 1, the h minus 1. Suppose you write is 2, h tend to 2, then you h minus 2. So this limit will be belong here. This when you using the LHL, so then you will h minus a. What is the a? This is the original limit. Or when you using the RHL, so then you will h plus a. What is the a here? Same thing. This is the original limit. According this here, this is the original limit here 0. Or this is the fixed 0 here. So then you can using a limit here, limit s tend to 0, 2h minus 0 plus 3. So when using the limit here, the s place is 0. This is also the result here come 3. Similarly RHL, now RHL, what limit x tend to here, original limit here 0, 0 plus fx, or value of the function here, limit x tend to 0 plus means, or what is the original function here? Because this function having RHL limit more than 0, the function value of the function here 3x plus 1. The value of this function when RHL limit, this one is the RHL more than 0, that means RHL limit, the value of the function will be 3x plus 1, 3x plus 1, 3 x plus 1 in this way. And after that you will put h place, you will change the x place, you will change s, this 0, and this plus sign you remove here. So then you will write here x place, okay, 3x, and h plus 0 and plus 3. Multiply inside here, this will become here 3x plus 3, or you will be put here x place. After multiply here, suppose you write here 3x plus 1, so you multiply here 3x plus 3, or in the x place you will write here 3h plus original limit here 0 and plus 3. In x place you will change the h plus original limit. What is the original limit here? When you find the value of the function, this is in this question original limit here 0, so then you write here 0. So then you putting here, so then using the limit here, the result will become here 3. The LHL limit or RHL limit both is same. Then you find the value of the function. Third thing, you will find the value of the function at equal to 0. The value of the function at actual, because this condition LHL limit at this will equal of the 0 also. This condition, when value of the function is 0, then the function will be using the 2x plus 3. So now f0, what is the function here? f 2x plus 3, or means 2, the 2 into 0 plus 3. This is the function fx, this is the function fx, or at x equal to 0, so then you are putting the value of 0, so then the answer here 0. That means function fx equal to this fx plus 3, then at x equal to 0, then 0 plus this, answer here comes 0, sorry 3. That means LHL equal to RHL equal to f0, answer is 3. Means 3 value, first, second and 3. The 3 LHL, value of the LHL, value of the RHL, and value of the function f0. The 3 of having the 3 LHL, RHL, and function of the having the value of the 3, because function fx value of the 3, RHL value here 3, and LHL value also here 3. So every part having the 3 and 3. So this is your correct answer. Then you can say the function is continuous at x equal to 3. Then you can say that then LHL RHL, then function is, the hence limit exists. Then you can say that hence limit is exist. This is your answer. When 3 conditions are same, then you can hence limit is exist. Or suppose any one condition is not exist, then you hence limit is not exist. Suppose if both are equal but LHL is not equal, then you can say कि limit does not exist. Suppose LHL RHL equal but this value of this function is not equal, then you can say कि limit is not exist. 3 on 1. Suppose any is not exist, then you write here answer is negative form. Suppose 3 are equal, then you can answer in positive form is exist.